Okay, so we're going to be starting with discrete random variables. So first thing we have to do is we have to check that it is in fact a discrete random variable. So for that to be true, that means that all of these numbers at the bottom here should add up to equal 1. So let's just double check that. Now, this won't get you marks in an exam. This is more just to help you guys remember. So when I'm adding them all together, just making sure that my decimal's in the right place. And 0.05. Perfect. So it adds up to 1, so we can say that, yes, this is a discrete probability distribution. Okay, so the first thing we're going to calculate is our expected value of z. So I find it hard sometimes to remember the formula for this, but I always remember the process. Now, the process for this one is you get this one times that one plus this one times that one plus. See, and I might not remember the actual formula, but I do remember the process. Now, we call the expected value EX. And I can say that EX is the sum of, and let's deconstruct what we just did, Z times PZ. Okay, or whatever letters we've got there. So it's the sum of all of those things. So let's start doing that calculation. Now, in an exam, I would show the working for this. So I'm going to do 1 times 0.15 plus 2. Now, I'm going to start putting these in brackets because it looks neater on this little sketch pad. So 2 times that one plus 3 times that one plus 4 times the next one plus 5 times the next one. Okay, and now that should be ready for me to put in my calculator. 1 bracket. Now, if you're at home, I would suggest you pause it at this point so that you can put it in the calculator and then you can skip over me doing it. That way you get some good calculator skill practice. Almost finished entering it in. There we go. Perfect. So our expected value of this function is 2. Now that makes sense because our expected value should be one of the numbers up here or between one of the numbers up here. So if we got a value that was maybe like 10, we know something's gone wrong. If I get a value less than 1, we know that something's gone wrong. So my answer should be one of these or between one of these. It's really the mean score. Okay, so that is part A. Let's calculate the variance next. Okay, so to calculate the variance of that one, we're going to do the same thing again, or similar, I should say. The formula is, now like last time, I don't remember the formula, but I remember the process. So it starts off as this squared times this plus this squared times this plus this squared times this. So remembering our process, we can say that it's going to be the sum of z squared times pz, subtract. Now, in the end, we're just subtracting our expected value squared, or our mean squared. Now, as I look on the formula sheet to see what we've got there, they've expressed that formula as E, or the expected value, bracket, x, and x inside is squared, because before we can multiply them, we have to square that term, minus EX squared. Now, if you have a quick look at the formula sheet, now you can access the formula sheet just by Googling QCAA Mathematical Methods formula sheet. We have some formulas on there for discrete random variables, but they aren't stuff that you guys will use in year 11. So this formula is definitely not given to you on your exam, so it's something you'll need to remember. Okay, so let's start plugging this in. We're going to first calculate EX squared. So to do that, all I have to do is 1 squared times 0.15 plus 2 squared times 0.2 plus 3 squared times 0.4. I'm going to stop talking. I bet that's annoying in your ears. Just kidding. I know you love my voice. Okay, so that will get us E of x squared. So I'm going to do a little cheat now, and I'm going to, instead of writing this all out again, because I'm lazy, I'm going to go back through what I've got above in my calculator. I'm just going to change it all into being squared. So I'm changing each of those z terms or those x terms. So they've got a square above them. You know, now that I go back through it, I've noticed that I've missed one of the terms. Okay, so then we should have had 4 squared times 0.2 bracket 0.2 bracket plus, now I'm making mistakes all over the place. This is where knowing how to edit would be good. 5 squared bracket execute. Okay, so when I chuck this first part in, I get 9. Now, normally what I would do is I would just take this answer from above and I would just square that answer. But I've made a mistake somewhere, so we're just going to go back into my calculation and remove all of those squares just to fix it up. Obviously, you won't need to do this if you didn't make a silly mistake to start off with. Okay, sorry, so this will be 2.8, and then to get E of x squared, or that mean squared, I'm going to square that answer, and that gets me 2.8 squared equals 7.84. Perfect. And now I can chuck that into my variance formula. Okay, so now we've got our variance x is equal to 9 minus 7.84. Chuck that in your calculator. 9 minus 7.84 gives me 1.16. So that's my final answer for the variance. You'll like the next part because it's super quick. To find the standard deviation of random variable x, or z in this case, all I have to do is square root the variance. So I'm going to square root 1.16 and get my answer. Now, if you work across the page in your exams, we'll get kind of cranky because you should be going down the page. But, you know, I'm running out of space here, so that's what you get. All right, and let's get that into a nice little decimal. Okay, so the standard deviation in this first case is 1.077. Now, it depends what you're rounding to here. I'm going to round to 3 decimal places. Normally, for statistics, we go to 4, because if I convert something to a percentage, then it ends up with 2 decimal places. Okay, we're going to leave question 2 for you guys to do on your own, and we're going to jump straight to question 3, which is one of my favourite style of questions, a sketchy question. Now, you know we love sketching because that's what makes the maths come alive. Okay, so we're looking at y equals 3 sine 2x minus 1 between our domain of 0 degrees all the way up to 180 degrees. We're going to state the function's period and the range of this function. So let's get started. Now we're going to just do this the way that we were shown in class, and then we'll fill this stuff in as we go. So first thing I'm going to identify is our amplitude. Then we're going to identify our B value. Then if we've got a phase shift, and then our C value or our D value. So A is our amplitude, and that will tell us how high and how low it goes from the equilibrium value, or the middle value, or the mean value, whatever you want to call it. So in this case, that's 3. Now, you'll identify it because it's the one that is in front of sine. It's the coefficient. Now, the other one that we've got there, our B value, this would normally be in a bracket, and B is the value in front of the X. So in this case, B is 2. We have no phase shift. If we did have a phase shift, it would be shown like this, some sort of value in there, but we don't have a phase shift, so it's 0. And our equilibrium value is at -1. So we're going to first find our period, then we'll find our max and our min. So the period of this function is equal to 2 pi over b. Now, we've already determined that b is equal to 2. These two will cancel out to be 1, and I'm left with pi. Or if I convert that to degrees, because this is in degrees, if it was in radians, I'd leave this as just pi. But pi as a degree is just 180 degrees. Next thing we're going to do is work out our max and our minimum. Okay, so our max is going to be the A value plus the D, and our minimum is going to be our I've done that the wrong way around, D minus our A, and this would be D plus A. For the first one, it doesn't matter because of the order. So we'll have 3 minus 1, and then we've got -1 minus 3. This will give me 2, and this one down here will give me -4. Now, when we sketch that, you'll see that that makes total sense. So now I can fill in the period. The period of this function is pi, or 180 degrees, because we're working in degrees. And our range is going to be between -4, including, up to 2. So it can take on any value of here between our range. Okay, so next thing that we want to do is we're going to make our little table so that we know what goes where. Because we know that we've got important information at the very beginning, at about 25% of the way through, at about 50% of the way through, and about 75 and 100% of the way. So the calculation that we're going to do to work this out is going to be our fraction multiplied by the period. Now, normally we'd say something about our C here as well, but we don't have one, so that doesn't matter. So our first one is going to be 0 times 180. So our initial spot that's going to be important is at 0 degrees. Now, normally my table would look a lot better, but you try writing on a sketch pad. Okay, so the next one is 1/4 times 180, which will be 45 degrees. The next one will be half of 180, which will be 90 degrees. The next one will be 3/4 times 180, which really means that I've got 3 lots of 45, which is 135 degrees. And lucky last is going to just be 1 times 180, so 180 degrees. Now, the next thing that I'm going to fill in is just what this means. So for this one, we're looking at a sine graph, which means we're going to start in the middle, go to a max, back to the middle, down to a min, back up to a mid. So I'm just going to write that next to it so I know what each of these coordinates along the x-axis really represent. Mid, max, mid, min, mid. Now remember, I really made that bomb sheet about sketching trigonometric functions. So if you need to go through another example, there's one there. It's really pretty. Go for gold. So now we're ready to sketch onto our function. If I knew how to edit, that would be the perfect time. Okay, so I can see here that my range needs to go between -4 and 2. I'm going to put my x-axis in between them, pretend like that line's straight, and then -1 is our middle value here. So this is what we were referring to when we were talking about our range earlier, which is your y values. This one here is going to be our x-axis, and we've already stated up here that it's going to go between 0 all the way to 180. Okay, so now I'm just going to break this up into 4 components because this is split nicely into 4. Bloop, bloop, bloop. That's 90, that's 135, that's 100, no, that's 45. Gotcha. And now I'm going to use my dots over here at 0 degrees on the x-axis. It's at the midpoint. Now, this one down here is where our middle of our graph is going to be. Then at 45 degrees, we're going up to a maximum. At 90 degrees, we're back down to the minimum. Pretend like mine is spaced nicely. Now, you've got plenty of time, so you can pause me and you can make yours look good. Okay, and then we go down here for that coordinate and then back up to the mid. Last thing to do is to join it with a beautiful curvy line. Oh, that's gorgeous. Okay, and I think that's all we're going to do for today.